Hello and welcome to lesson 6 in Spiral 2. So today we're looking at equivalent ratios, and what we want to be able to do is demonstrate understanding of equivalent ratios and related real-world applications. So it is a little bit busy here, but it's really not too much to it. It looks worse than it really is. So first of all, two ratios are equivalent if they are the same when reduced to lowest terms. So for example, the first one here, all right, if we look at it, it is made up of 1, 2, 3 parts. All right. And we've colored one section in. So it is 1/3. The second one here, this is the whole. There's 1, 2, 3, 4, 5, 6 times 2. So there's 12 sections, and we've colored 1, 2, 3, and 4 of them. All right. So 1/3 and 4/12. That's how we would represent our colored area. So very similar to how we approach our fractions. So I'm going to work down here. So example 1. What fraction of each diagram is yellow? Well, we said already the first one, so number 1, was 1/3. The second one was 4/12. Now, this is a fraction that can be reduced to lowest terms. I know I can divide the top by 4 and the bottom by 4 evenly. 4 divided by 4 is 1. 12 divided by 4 is 3. So what do we notice? They are equal. They are equal. All right, so both of them represent 1/3. Now let's go back and look at the picture. We knew this already because if this is the whole, this section here, the yellow, was 1/3 of the chocolate bar. Now this one, if we look at this whole and I divide it into thirds, it too is equal 1/3 of the chocolate bar's color. So it does make sense that 4/12 reduces down to 1/3. Second one is write the ratio of yellow to white. So let's talk about jump up here for a second. What is the difference between a fraction and a ratio? Okay, the difference is form. All right, that's the only difference right there, form. Okay, so fraction, it would be A over B. A ratio looks like this, A, and these dot, dot, dot mean 2. All right, so 3 to 4, 5 to 6, and so on and so forth. So now we can go back to example 2. Write the ratio of yellow to white for each of the rectangles above. So for the first one, it was 1 yellow to 2 white. So that's for the first one. Number 1, number 2. And the second one would be 4 to 8. And very similar to fractions, the same rules apply here. We can reduce it. And we see that both are divisible by 4. So we end up with an equivalent ratio of 1 to 2. All right. So if we go over on the other side, and this is imaginary, because if I was teaching you in class, we'd fill this in. So this particular class has, and I'm going to make it up. So let's say we have 16 boys and let's go with 9 girls. Okay. What fraction is boys? What's our total? So a fraction always has a total. Okay, so the B is always the total, and A is how much you have. All right, so what's the total here? So the total is 16 plus 9 equals 25. So what fraction is boys? Well, we have 16, and there is 25 in the class. What fraction is girls? Well, 9 girls in a class of 25. What is the ratio of boys to girls? So we have to write it in that order. B to G would equal 16 boys to 9 girls. What is the ratio of girls to boys? So again, that's why it's important. Order matters here. So G to B would be 9 to 16. It contains the same information. It's just asking for it in a different format. Okay, so communication is very important on how you write that. On to the next one. There are 3 different ways to write a ratio. Each are illustrated in the next example. So in example 3, there are 3 forms. For each of the following ratios, determine, and it should be just n, equivalent ratio by dividing or multiplying. So the first is what we'll call it, it's a ratio. Okay, so an equivalent ratio, if I have 1 to 5, what's an equivalent? Well, let's do it in terms of boys to girls. We want 1 boy for every 5 girls. Well, what happens if 2 boys shows up? Well, then we would need 10 girls. What happens if 10 girls show up? Or sorry, 10 boys show up? Well, then we would need 50 girls. So all we're doing is we're just magnifying each of the term on either side by the both amount. So we multiplied by here, multiplied by 2, here I multiplied by 10. It does not matter. B, this is an example of words. Okay, you can express a ratio in words. So what's an equivalent expression? 120 to 60. Well, 120 and 60 is 120 is twice 60, so we can cut it, divide both sides by 60. So we could say 2 to 1. We could double both sides. So 120 times 2 is 240, or 60 times 2 is 120. So 240 to 120. And your third and final form is the fraction. So 3 to 5, or 3 out of 5, or 3/5, we could double everything. So it would be 6 out of 10, or we could multiply it by 10 and have 30 out of 50. All right, so there's your 3 forms, and that's how you find equivalent values. Okay. Example number 4 here. What are the 2 multiplication relationships in here? So what we need to figure out, they're telling us that these 2 ratios are equal. So how are they equal? Well, what I do is I look at the first term and compare it to the first term, because remember, it has to be the same. So if, for example, this represented boys, this has to be boys. So what is the relationship to go from 12 boys to 24 boys? Well, 12 times blank is going to give me 24, and hopefully most people are saying 2. So check the other one. Does it work for the other one? So if we multiply the first term by 2, we got it. 36 times 2 is 72. So therefore, the relationship is doubled, or multiplied by 2, or twice, however you want to word it. Which allows me to look at the next example then. So how do we find this missing value? Well, we know, for example, I'll go back to the whole boy issue. Let's say we have 5 boys one day, 15 boys the next day, but the ratio stays the same. Well, how did we go from 5 to 15? Well, we brought in 3 times as many boys. Well, to keep balance in the world, keep it so that the boys don't get into trouble, we better bring in the same ratio of girls. So we better multiply the amount of girls by 3. So that means we're going to end up with 90. So therefore, the missing amount is 90. And example 6. So what have they done here? Well, the first one is now the unknown, so I can't just use it. So I'm going to go to the second one. So let's use the second one. So for example, in this one, so they told us boys to girls, boys to girls. Well, this time we don't know how many boys are in the new class. We know how many girls. So 12 times, if you work it out, 12 times 4 gives me 48. Well, I have to do the same to the other term. So I'm going to multiply it by 4. So that means, therefore, 4 times 7, the value of P is 28. All right. So if we flip over, I'm just going to finish. I have two more quick examples here. The next one is same idea. 12 to 18. Actually, this is going to be a little bit more tricky. I want to take my time with this. So I'm going to cut it off here, and I will continue or finish these last two examples in the final video.